So today we're going to talk about some absolute value inequalities. This can get a little bit tricky. But to get a better understanding of it, we're going to start off with equalities, okay? So for example, if I asked, remember, absolute value is the distance from zero. So the smallest absolute value can be is zero. It can never be negative, all right? So if I did something like this, okay, the absolute value of x equals 3. Now, where on the number line, we can actually just talk through this and answer it, and then I'll show you the procedure, and I'll make more sense when we get to the inequalities. Where on the number line are you 3 units from 0? And I'm hoping that you say, well, at the number 3 and at the number -3. That's absolutely right. Your answers would be 3 and -3, right? Okay. Because if I plugged in 3 here, the absolute value of 3 is 3, but the absolute value of -3 is 3 as well. So the procedure for solving this, and there's not much solving to do here, but look at this. You want to have everything contained within the absolute value bars on one side of the equation. In other words, there's nothing else on this side except the absolute value bars and what's inside. And that's what we have here. So when you have that, what you do is you remove the bars and rewrite the same exact thing just with no bars. But then you write a second equation over here and you change the sign of this thing. And we're actually done right there. Our answers are 3 or -3. Now watch this one. This one will be a little bit more involved, okay? Okay, so check this out. So remember, you never distribute into the bars. You can't do that, okay? The bars is kind of like its own entity. So you want to get everything inside the bars by itself on one side. So here we would have to move over the 6. And we have to get rid of this 2. Remember, something written in front of something else means multiplication. So we would divide, and we would have the absolute value of x equals 5. Remove the bars, and then rewrite like that. And we're done there as well. Okay. You can check it, see if each one works. You take the 5, absolute value of 5 is 5, 2 times 5 is 10, 10 minus 6 is 4. It would work with the other one as well. So here, let's do one that's even more involved. Okay. Let's do, well, let's just do a little bit differently here. X minus 1 equals 8. So you see everything's contained within the bars on the left-hand side. So we remove the bars and rewrite it exactly like it is. Now we leave a little space, and over here, we write it exactly like it is, but we change the sign of this thing to -8. Now we have some work to do. We have to solve them both. It's not hard. X equals 9. X equals -7. And both of these answers are correct because 9 minus 1 is 8, and the absolute value of 8 is 8. That works. -7 minus 1 is -8, but the absolute value of -8 is 8. So you see, a lot of these, most of these will have 2 answers because you have to look at both sides of the number line. Okay? Both sides of the number line. Okay, one more with the equation. Let's go with -4. And I don't know. I'm just going to go with 8. So again, we want to get the bars by itself first. So we got to move the 4 over. So you get 12 now. Remember, never distribute into the bars. Get rid of this 2 by dividing both sides by 2. Absolute value of x minus 3 equals 6. Now everything on the left-hand side is in the bars. Whoops. So we remove the bars and rewrite it exactly as written. But then over here, we write it a second time and change that to a negative 6. Move the 3 over. Move the 3 over by adding. And you have these two answers. Okay. Now, when you get to inequalities, it's a little bit more complex. And there's going to be graphing involved and all that stuff. So, watch this. So, absolute value of x is greater than 3. That means where on the number line are you more than 3 units from 0? Of course, that would be beyond the 3 to the right and beyond the negative 3 to the left. Okay? So you're going to have an oars of a boat type inequality. Now, again, like we did before, everything's contained here, so we remove the bars and write it exactly as before. But now what's key is a couple things here. When we remove the bars and this says greater, we write the word or here. Greater or. On this, when we write the second inequality, we have to not only change this to a negative 3, but we also have to switch that direction. And then we would graph this. Okay, we would have 3, negative 3. This is going to be oars of a boat. There you go. So the only thing that's different with the inequality is you have to switch this sign when you make the second part. Let me do one that's a little bit more involved. So here, this is less than, so where are you within 6 units of 0? Well, you got this little adjustment factor in here you have to take into account. So everything's within the bars. So we remove the bars, rewrite it exactly. But this is now an and problem. Whenever see how this was less than, and, greater, or. Over here, we're going to switch the direction, negative 6. Add 2. And here you get greater than or equal to negative 4. And this is a barbell. Okay. Anything with a less than absolute value is going to be a barbell. Anything with greater is going to be oars of a boat. Remember, when you do the second thing, you have to switch the direction of the inequality. Okay. And you have to change the sign. Okay. I'm going to have a second video that's going to have some more of these problems as well. So you can look at that second video as well. This is just kind of introductory. I'm going to do just one more problem on this one. Check this out. How about absolute value of x equals negative 10? Now remember, absolute value can't be negative. There is no number that is negative 10 units away from 0. Remember, distance cannot be negative. So this is no solution. Okay, absolute value cannot be negative. It's not possible. So there's going to be a second video. And again, the zoom, there's going to be a lot more detail going on in the zoom. All right. So you definitely want to be at the zoom. But this is a good backup just in case. But there's a second video at least in section 3.7.